Hi everybody! So in today's video we're going to be talking about something called the intermediate value theorem, which is connected to the investigation of this theorem that we did today in class. Now the intermediate value theorem, I like to think about this as the in-between value theorem. And we're going to talk a little bit about why I call it that, but basically what the intermediate value theorem allows us to do is to guarantee values that are in between known values for a function under certain conditions. So let's start with those conditions. In order to use this theorem, we need to know that f of x, which is our function, is continuous over our given interval. So if I was to think about sort of why it has to be continuous, I would go back to the examples we did today in class. We could guarantee certain speeds on the speedometer because you weren't allowed to jump between speeds, but we couldn't guarantee certain iPhone prices because iPhone prices could jump around. An example of a function that we could guarantee would be continuous would be this one. And this is the function I'm going to use for our example today. We're going to use x minus 2 squared plus 1. Now I know that this is a continuous function because all parabolas are continuous. They're not going to have any jumps or infinite discontinuities or holes because this is just a parabola. If I were to sketch a picture of that function, I could also determine if it was continuous. So I'm going to go ahead and just sketch a quick picture of this function. This is going to be a parabola that was shifted to the right 2 spaces and up 1 space. So I'm going to work primarily in the first quadrant here. So if I shift my vertex right 2 spaces and up 1 space, my vertex would be here. And then I can go over 1, up 1, and then over 1, up 3. And I know that my parabola is symmetric. So another way that I would know that this was a continuous function is that if I look at the graph, there are no holes, there are no asymptotes, there are no jumps, nothing like that crazy is happening. So maybe I should make a note of that here. No holes, asymptotes, or jumps. Now we only need to be continuous over our desired interval. For this particular example that we're going to write out, our interval from A to B, which gives specific x values, I'm going to use the interval from 1 to 4. Now this is my A and this is my B. So on this graph, A would be here and B would be here. The reason it's important that we need to be continuous over a specific interval is that there are some functions that have discontinuities somewhere, but as long as those discontinuities are not within my desired interval, it's okay that they exist. It just has to be continuous between the values that we're looking at. Now the other condition, before we can even start using this theorem, is that the number that we are trying to guarantee has to be in between, again going back to in between, the values that we have at our endpoints. So the number we're trying to guarantee we usually call m. This is the number we're trying to guarantee. So in our examples today in class, this would be like trying to say, can you promise me there's a certain speed that you would travel? Can you tell me for sure you go 40 miles per hour at some point? The number we're trying to guarantee has to be in between the y values of the endpoints. Now on that graph, the y value of my first endpoint would be here, and the y value of my second endpoint would be here. So the a and the b are the x values. The f of a and the f of b are the specific y values that we get when we take those numbers, those x values, and plug them into our function. If you meet both of these conditions, if you are continuous, and if the number you're trying to promise is between the numbers at the endpoints, then we can guarantee there must exist, so we can promise there must exist a number, we usually call it C, which is a specific x value between A and B. So C has to be somewhere in here between A and B, such that the y value we were trying to promise is the y value you get by plugging in C. So we would write f of C, so when I plug in that x value, I'm going to get the y value I was trying to promise. So in other words, we can guarantee that we traveled a certain speed at some value. Now this does not allow us to say exactly what value that was, it just allows us to say that it happened somewhere. So what do these look like on an AP test or on our assessments? So suppose that, and this should say f of x, I apologize for that typo. Suppose that f of x equals 25 minus x squared. Can you guarantee, so as soon as you see that question, can you guarantee, it tells you you're using a theorem here, a value c between -2 and 8, such that f of c equals 0. So what is this asking me? Well, remember, up here we said we had to be continuous on a certain interval. Our y value has to be between these two y values. So down here, I can see that the two x values that I have to be between are -2 and 8. So we're looking at the interval from -2 to 8. And we want to know if our function will ever equal 0. So that's my desired y value. First, we're going to check our conditions. So we need to check to see if we are continuous. Since f of x is equal to 25 minus x squared, which is just a parabola, I can say yes, we are continuous because this is a parabola. So it's continuous everywhere. The second question I need to ask myself is my desired value, which is 0, between f of whatever my first x value is, which is -2, and f of whatever my second y value is, which is 8. So in order to figure that out, I'm going to need to figure out my y values. So f of -2, would be 25 minus 4, which is 21, and f of 8 would be 25 minus 16, which is 9. Oh, I'm sorry. F of 8 would be 25 minus 64. What am I doing? 25 minus 64, which would be 39. -39. Since 0 is between 21 and -39, we have met both of our conditions. We are continuous, and the value we're trying to guarantee is between the output values at the endpoints. So now it's just a matter of writing up my result correctly. Now the language here really matters. You have to say this a certain way because you need to show that you've met the conditions and that you understand the conclusion as a result of those conditions. So here's how we're going to write this up. We're going to say since f of x is continuous over the interval and we're going to write our specific interval, -2, 8. And the value we want is between these two. So we need to say that. So we're going to say f of 8 is less than the value we wanted, which was 0, which is less than f of -2. So I'm just saying 0 is between these two numbers. F of 8 was less than that, and f of -2 was more than that. The IVT, which we can abbreviate instead of writing out intermediate value theorem, guarantees that f of c equals 0. So I'm taking this directly from the instructions. So the instructions here said we wanted f of c equal to 0. For some c value where -2 is less than c is less than 8. So again, I'm taking this directly from the instructions. So what I'm doing here is I'm stating the conditions that I found here, and then I'm copying the thing that I can guarantee out of the question so that I get the phrasing correct. So since f of x is continuous over this interval, that was the first condition, and 0 is between these two y values, that was the second condition, the intermediate value theorem guarantees that f of c equals 0 for some c value where -2 is less than c is less than 8. So I'm copying the conclusion out of the question. That way you can kind of make sure you write that correctly. You're just kind of copying it out of the question. All right, number 2, let's try this one. So number 2 is the same function, f of x equals 25 minus x squared. Can we guarantee a value c between 2 and 5? So I've changed the interval. Instead of between -2 and 8, it's 2 and 5, such that f of c equals -3. And I've changed the desired y value that we're trying to guarantee. Now the process here is going to be first, check the conditions. You always have to do this first, because if you don't meet both of these conditions, you're kind of done. You can't use the IVT, so you can't guarantee anything. First, we have to check to see if we're continuous. The answer is yes, because again, we're working with a parabola, which is continuous everywhere. The second thing we need to check is our desired y value is -3 between, and we need to check our input values. We need to plug those in and check the outputs. So between f of 2 and f of 5. So first, let's check f of 2. So if I plug 2 into here, I have 25 minus 4, which is 21. And if I plug 5 into here, I have 25 minus 25, which is 0. Now, -3 is not between (21) and 0. So this is an example of where after we check the conditions, we realize we have not satisfied both conditions. So here's what we would say. Since -3 is not between f of 2 and f of 5, the IVT cannot be applied. Let's take a look at some more examples. So this is an example of where the IVT can be applied, and how do you write that? This is an example of where the IVT cannot be applied, and how do you write that? Let's take a look at some more examples. So consider the function f of x equals x cubed plus 1 on the interval from 1 to 3. According to the intermediate value theorem, there exists a number c between 1 and 3 such that f of c equals, and what they're doing here is they're asking you which number can you promise. Now the IVT says you have to be continuous. So we're going to check our conditions, which I know to do because it's telling me to use the intermediate value theorem. The IVT says if we check our conditions, are we continuous? The answer is yes, because it's a cubic function, which is always continuous everywhere. And the second condition is our value, whatever m we're trying to promise, between f of 1, which is our first x value, and f of 3, which is our second x value. So if we plug those in, f of 1 would be 2, and f of 3 would be 28. So in other words, we can promise all the numbers between 2 and 28. Now if I look at this list, the only number on this list that's between 2 and 28 would be 3.56. So that's the number that I would be able to guarantee using the intermediate value theorem. For number 4, it says consider the continuous function in the table below. So they're telling you that f of x, which is in this table, is continuous. They're telling you you meet the first condition. If the intermediate value theorem can be applied on the interval -4, 4, what is the minimum number of zeros for the function on the interval? What that means is how many times can you guarantee that y is equal to 0? Well, we're going to be able to guarantee that y is equal to 0 whenever 0 is between our y values that we can see. So just like here, we could guarantee all the numbers between these two y values, 0 must be between our y values to be able to make that promise. 0 is between -2 and 1. So that's one time I have to equal 0. 0 is what I get here. And the only other time that 0 is between my y values is between 1 and -2. So that makes 3 total times that I can guarantee my y value must be 0. Finally, our last example is, let f be a continuous function such that f of 2 is equal to 5 and f of 5 is equal to 2. And let's let h of x equal f of x minus x. Explain why there must be a value r between 2 and 5 such that h of r equals 0. As soon as we see this, that we're trying to guarantee that our output must be 0, we are trying to guarantee that y equals 0, then we must use the intermediate value theorem. So first, let's check our conditions. Are we continuous? Well, it says in the directions that f is a continuous function. Is 0 between h of 2, which is my first x value, and h of 5, which is my second x value? Well, that's the question we need to figure out. So first, let's find h of 2. Now to find h of 2, I'm going to plug in 2 for all of the x's in this equation. So I'm going to have f of 2 minus 2. F of 2, it says here, is 5. So 5 minus 2 gives me that h of 2 is 3. Now I'm going to find h of 5. H of 5 would be f of 5 minus 5. I'm sorry. And f of 5 is 2, so I would have 2 minus 5, which is negative 3. 0 is between 3 and negative 3. So that tells me I've satisfied both of the conditions of the intermediate value theorem. So here's what I would write. Since h of x is continuous on the interval, and they give me my specific interval here, 2 to 5. And since 0 is between these two outputs, so I would say h of 5 is less than 0, which is less than h of 2. The intermediate value theorem guarantees that h of r must equal 0. So I'm just copying the instructions here. This is directly from the instructions. And then I'm going to say for some value r, two is less than r is less than 5. I'm just copying the instructions. So I'm copying kind of the question in part of my answer. So since I checked these things and they worked out, then I can guarantee this thing that you asked me to guarantee. All right, thank you guys so much for watching. Good luck with your practice, and I will see you for some more practice tomorrow. Have a good afternoon.